All right. Happy weekend, grade 7. This is your final review for your probability test that will take place on Tuesday. Okay? So make sure you watch the video and slap that like button if you enjoy whichever, and make sure you subscribe to the account. So the first question. So the first question says, what is the probability, and in the brackets it says G, of drawing a G. That's our favorable outcome. So since it's one bag, we don't have to do a tree diagram, and we don't have to do a table because it's just one outcome. So reaching into that bag, how many possible outcomes are there? There are 1, 2, 3, 4, 5 possible outcomes. And of those possible outcomes, the favorable outcome of G, there is just one of them. So the theoretical probability of reaching into that bag and drawing a G is 1 chance out of 5, which as a decimal is 0.2, and as a percentage is 20% chance. So there's a 20% chance of drawing the G from the bag. Question 2 says, using a tree diagram, what is the probability of heads, heads, heads? Well, I'm going to press pause here and draw the tree diagram. And once I have the tree diagram drawn, I really have, the first event is this top row right here. It can either be a heads or it can be a tails. The second event can either be a heads or tails on the second flip or a heads and tails on the other side. And what this means is if I take my highlighter, actually, I'll grab a highlighter. If I was to follow heads on the first flip, heads on the second flip, heads on the third flip, that yellow pathway shows all 3 events. If I look at heads on the first, heads on the second, and tails on the third, that would be the pathway. So at the end of each of these branches, what I can actually write is what happened at the end of that branch. This one would be heads, heads, tails. And if I actually press pause here, the end of all of those branches, there are 8 possible outcomes, and each of them is located at the end of the branch. So if you follow each of these branches down, you'll see that those 8 outcomes are all the possible outcomes of that event. So of all of those, there is only one, this one right here, that is heads, heads, heads. So the theoretical probability of flipping a heads, heads, heads is 1 chance out of 8, which is 0.125 as a decimal, which is 12.5% as a percentage. The third question says, what's the probability of an A and then an A? So we'll call this one event 1, and we'll call this one event 2, and we'll draw a table. So it doesn't matter where you put event 1 and 2. I just like putting the first one on top. So I'm going to put an A, and an A, and an A, and a B, and a C. And down here I'm going to put my second event, which is going to be an A, a B, and a C. So when I make my table, which is the outcome of grade 7, I can clearly see inside this little area here, these are all my possible outcomes. So if I was to fill all of those in, when I fill those all in, I have 15 possible outcomes. And of them, that one, that one, that one, those 3 are the only AAs in the entire table. So as a fraction, we say it's 3 chances out of 15. Or in lowest terms, 1 chance out of 5, which most of us know is 0.2, which as a percentage is 20%. Now, if I didn't know 3 out of 15 in lowest terms, I could say 3 divided by 15 with a calculator. When I take the, oh, where's my calculator gone? When I take the calculator over and go 3 divided by 15, it still says decimal 2, right? So I could just figure it out that way if I didn't know that in lowest terms it was 1/5 and 1/5 was 2/10. So that's another way you could change it to a percentage. The next question says, using a tree diagram, what is the probability of an A on the first, a B in the second bag, and a C in the third bag? Definitely going to press pause here. Okay, now that the tree diagram is made, same thing as the second question, I think it was, or the first question. Again, second question. If I take my highlighter here, if I follow this branch down here, if I go B on the first, A on the second, and B on the third, oh, that didn't work out so well. That would have been a B, B, B. So if I put at the end of each of these branches the outcomes, I'm going to have something that looks a little bit like this. It's way too much work to write it all out, but I can see from this first part of my tree, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 different outcomes. And if I was to do it in all the other ones, each of these other parts of the tree would have 9. So in total, there are 27 possible outcomes. But of all these branches, A has to be the first, which means it can only happen in this one, because the second and third part of my tree are B in the first one. So A on the first is right here. I'll take my highlighter again. A right here. B on my second, and C on my third is this A, B, C right here. And of all 27, only one of those is A, B, C, which means 1 out of 27 is my fraction. As a decimal, I go 1 divided by 27, which is 0.030, 0.030, is that 30 or 337, which is approximately 37 thousandths, which is approximately 3.7 hundredths, which is approximately a 3.7% chance of drawing ABC. The next question, that is the next question. The next question is, what is the probability of a doubles? Okay, so if I make my table, the first bag would be a 1, a 2, a 3, a 4, a 5, a 6, a 7, an 8, and a 9. And the second one, same thing. So when I make my table, I can clearly see that there are 81 possible combinations. Now doubles, if I put a check mark in all of the ones that are doubles, this would be 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, and 9, 9. That is 9 chances out of 81. So theoretically, pulling out a double, 1 from the bag 1 and a 1 from bag 2, or a 2 from bag 1 and a 2 from bag 2, there are 9 chances out of 81 possible outcomes, which 9 divided by 81 equals 0.1 repeating, which is approximately 11.1%. Now I realize I skipped a question, so I'll have to go back and paste that at the end of this video. Just watch it at the end of the video. Our next one, I think I got just enough time. So all the students' names in this class are placed in a hat. That is 32 students. What is the probability that yours is not chosen, since you are the only one, unless, of course, there are 2 Ellies or 2 Ellas or 2 Wills, or, God forbid, 2 Bradens. If there was only one of you, then 31 people in that class didn't have your name. And 31 divided by 32 as a percentage, or as a decimal, is 0.96875, which is approximately 96.875% probability, or roughly 97 if you want it, or 96.9%. All these are pretty good answers. Approximately, that's the probability that you're not going to have your name drawn. And the second to last one, is this the last one or second last? The last one we can answer because the other one's theoretical. It says, how many B's are missing? So I do know that the probability is 40%. So there are 2 A's, and I don't know how many are in the bag, but I do know that that's 40%. So the only fraction I can make that has a value of 40 cents is 2 chances out of 5, which means if there's 5 total B's in the bag, or 5 total chips in the bag, 3 of them must be B's. So how many are missing? You can say 2 are missing, or there are 3 B's in the bag. Either one's fine. Okay? And which one did I miss here? Did I miss this one? No. Let's go back and find 5. I don't even know what 5 is. Let's go back. Oh, right. What's the probability of Braden and Jessie? So if we do our table of, I'll just do a new page here. So for Braden, you can have Braden, you can have Brock, and you can have Ethan. Okay, just watch the video to finish it. I'll have it done. And then we put Ethan here. And Jessie, Kate, and Ellie are your other ones. So we have 9 possible combinations. 9 possible combinations. And the one that we're looking for is this Braden Jessie. So of all of them, there is only one chance out of 9 that Braden and Jessie, and we actually had this percentage already. Because if I take my calculator and go 1 divided by 9, I get that same 0.1 repeating, which is approximately 11.1% probability. Okay, so that's the answer for question 5. And the last one that we didn't answer is right here. It says conduct an experiment using 5 cents to show the difference between theoretical probability and experimental probability. And if we think about that, the theoretical probability of flipping a heads, you have either a heads or a tails. So there are only 2 possible outcomes for flipping a coin, one of which is a heads. So theoretical probability of that event happening is 50%. Okay? Now when you flip your 20 coins, everybody's not going to all have the same answer. You're going to have some of you have the same answer, some of you are going to have different. I heard somebody say they had 13 chances out of 20. I heard a lot of people had exactly 10 out of 20. Some people had 11 out of 20. Some people had 9 out of 20. So if we think about these as theoretical probability or experimental, her experimental probability came out to be 65% of them were heads. This one was 50%. This one was 55%. This one was 45%. But the theoretical probability doesn't always have to jive with the experimental probability, but the more times you did it, if this number down here was not 20 but rather 2,000 times, you would find that the number of times that it happened heads would probably get closer to 50%. So the more you do it, the more it actually approaches the theoretical probability. Hopefully that helped you for your test. Remember, you're going to write your test Tuesday afternoon, last period. So on Tuesday afternoon, last period, that's when you write your test. Good luck to everybody.